Good evening.
Good evening, ma'am.
Good evening, children. How are you all? Am I audible?
Yes, ma'am. Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, beta. So tell me about your homework.
Ma'am, almost completed.
Aryan, your homework, Abhinav.
I'll share after class, ma'am.
Sudhamshu. I'll share after class.
Good evening, ma'am.
Good evening. Abhinav, your homework, beta.
Yes, ma'am, I was going to say about that. I am
You
still
have done?
doing it. No, ma'am, like in work in progress, I'll do it.
When you will do it?
I'll post it as soon as I complete it.
Actually, grade 10, you people are not taking anything seriously. Right? Okay, then fine. Today I'm going to start new chapter, beta. That is your circles. After circle, we will proceed to area related to circle. Okay? Am I audible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes.
Okay. So first of all, what is circle, beta? What is circle? Circle basically is a closed plane, right, beta? Closed plane
Yes, ma'am.
Yes.
consisting of all those points of the plane which are equidistant from a fixed point, right, beta?
Yes, ma'am.
Suppose you have this circle, right? So fixed point is this here. This is your fixed point, right? This is your center. And from this fixed point, all these points having same distance, right? Constant distance. So
Yes,
these
ma'am.
are called the radii, right? These are called the radius, or you can say the radii. Then after that, what is the tangent to a circle?
Ma'am, it's an external line that intersects the circle only at one point.
Yes. Suppose this is your circle, right? And I have drawn a line. Okay. So it will touch the circle or intersect the circle only at exact only one point. So a tangent to a circle is a line that intersects circle exactly at one point. Clear this thing?
Yes, ma'am.
Yes.
Yes, ma'am.
Now next is, this is the theorem, and this is quite important theorem, that the tangent at any point of a circle is perpendicular to the radius through the point of contact. Through the point of contact. So how we will prove this? This theorem came so many times in exam. So this is a theorem. So first of all, we will write what is given here. Right, beta? We will write what is given. So what is given? A circle with center. First of all, we will draw the figure, because without figure, we can't do anything. So you have drawn a figure and it is having a center O, and they are saying the tangent at any point of a circle is perpendicular to the radius through the point of contact.
Ma'am.
So suppose any tangent you have drawn, right?
Ma'am,
And a line. Yes, beta?
so I have a doubt in this theorem, ma'am.
Yeah.
So any line, like, which is
Yes,
the
any
shortest to
line.
the,
Suppose you are drawing any line like this. Yes. If
like,
you will
from the
draw
radius,
any line,
if it's the shortest to
it will be
the,
perpendicular.
it will be, okay, ma'am. No
Fine.
slant
The
can be
theorem is that it
perpendicular.
always be perpendicular. Right.
We can determine if it's slant by,
Okay.
ma'am.
Yes, beta.
We can determine if the line is not perpendicular by measuring its distance, right? Like if it's
Yeah.
above, like it's above the radius.
Yes, Vipin. So first of all, you will write given. So a circle with radius O, sorry, with center O and radius. Suppose this is your P, this is your AB. Okay. Radius OP and AB is a tangent drawn to the circle. Okay, now to prove. What we have to prove? We have to prove this OP is perpendicular to AB. Perpendicular means that it will make 90-degree angle.
Yes, ma'am.
Right, children? Yes. So now we will do the construction part first. So you will join O to B first. O to B. Now let this point be R on. Clear? So you will write, since B is a point on a tangent. Right, beta? On a tangent other than contact point P.
Ma'am, can you scroll down?
Yeah. Other than contact point P. So this B lies outside the circle now. Right, beta?
Yes, ma'am.
Yeah. So B lies outside the circle. So because every point on the tangent to a circle other than this point P, it always lies outside the circle. So we will let that OB intersects circle at point R, where it intersects at point R. Clear? So it means your OB will be equal to OR plus RB. Right, beta? See the hypotenuse? OB will be equal to OR plus RB. Is it clear?
Yes, ma'am.
Right? Now, children, if you will observe that your OB is greater than OR or not? From the figure, right? We can observe this thing now. That OB is greater than OR.
Yes, ma'am.
Yes, ma'am.
Correct? And if you are seeing that OP is equal to OR, both are the radii of the circle, right? Children, please speak up.
Yes, ma'am.
This OP and this OR, both are the radii of the circle,
Yes, ma'am.
right? So it implies that OB is greater than OP, right?
Yes, ma'am.
Instead of OR, I have written here OP. Clear?
You got it, ma'am.
Right? So therefore, OP is less than OQ. So as OP is shorter than OQ, OB, sorry,
OP, right? OB, okay.
OB, shorter than B, so OP is the shortest distance, right, beta? Is it shorter? So OP
Yes,
is
ma'am.
the shortest distance between O,
Between O and the
between,
tangent.
yes, between O and the line AB, right, beta?
Yes, ma'am.
Yeah. So, but the shorter distance between a line and a line is perpendicular distance from the point on the line. So, therefore, you will write, hence, OP is perpendicular to A. This thing we have to prove. Fine?
Yes, ma'am.
So, please note this. This is quite important. And so many times this theorem came in your exams also. In board exams.
Ma'am, can you scroll down a little?
Yeah, beta.
Done, ma'am.
Fine?
I'm a bit one line up.
One line up. Okay. Abhinav, written?
Yes, ma'am. The whole thing's done.
Okay.
Done, ma'am.
Done.
Okay. All have written, children?
1 minute, ma'am.
Okay. Because next theorem is also very, very important. When two tangents are drawn from an external point to a circle, then they will be equal, they will be of equal length.
Completed, ma'am.
Show me a thumbs up, children. May I proceed to next? Siddhishri? Meher? Sudhamshu? Huria? Done?
Done, ma'am.
Okay. Now next theorem is if two tangents are drawn from an external point, it means the point will be only one from where you will draw two tangents, okay, from an external point. Then the lengths of tangent are equal. Equal. Okay. So, first of all, you will draw the circle. Clear, beta? Now, you will draw the tangent. So, like this. Then draw second tangent. Okay. So now this is your center O. So you will write first of all given. What is given? Let this be P. This is A. This is B. Okay. So you will write a circle with center O and PA and PB are its tangents. Okay. So now to prove, what you have to prove? PA is equal to PB. Clear? So now, construction. So you will draw line from O to the point of contact A. And we know that it always perpendicular, right, beta?
Yes, ma'am.
And this is also perpendicular. Clear?
Okay, ma'am.
So now construction, we will join P to O. Okay. So you will write join O to A, OA and OB and OP. Clear? Then prove. Now we have to prove this PA is equal to PB. So what we can do? We can take these two triangles now. Angle A is equal to angle B, right? And this OA will be equal to OB and OP is common. Am I correct, children? So you will take in triangle OAP and triangle OBP. Is it fine?
And we're just going to prove that they're congruent, right?
Yes, we will prove congruent and then by CPCT we will prove PA is equal to PB. Okay.
Yes.
So you will write OA is equal to OB, radii of the circle. And angle A is equal to angle B. You will write line drawn from center to the point of contact is always perpendicular. Clear? Because you need to specify the reason always. So PO will be equal to OP common. Now we have got three things. So you will write triangle OAP is congruent to triangle OBP. By which criteria? RHS.
Ma'am,
Right
can you
angle,
scroll down?
hypotenuse, right beta? And perpendicular. Clear?
Yes,
RHS side. So now you will write, therefore, PA will be equal to PB by CPCT. Hence proof. Very, very important theorem. This theorem also came so many times in your exam. Okay?
yes, ma'am.
Very, very important. Please note it down it fast.
Noted, ma'am.
You are writing side by side only.
Yes, ma'am.
Ma'am, it's easy, so fast. Done, ma'am.
Ma'am, can you
Okay.
scroll down?
Yeah.
Ma'am, do we have another theorem for angles?
Yeah, beta, angles. By CPCT, you can prove angles also, right?
Oh, okay,
No,
ma'am.
That this OP divides this angle OAPB. Right, beta?
Yes, ma'am.
You all have written, children. Kindly show me your thumbs up. Meher done. Sumok, Huria, Siddhishri, Rizwana.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Aryan done, beta.
Yes, ma'am.
May I proceed to next?
Yes, ma'am.
See, beta.
Done, ma'am.
Okay. Suppose the question came like this. Two concentric circle. What is concentric, beta?
Ma'am, it's like one circle inside another.
Having same center, right?
Yes, ma'am.
Circles of radius 5 centimeter and 3 centimeter. Fine. And then find the length of the chord. And in grade 9, you have studied that when a line is drawn from the center to the chord, it always bisects the chord. Have you remembered that theorem? Length of the chord of larger circle. Which touches the smaller. Have you remembered, children, that theorem? No reply at all, no?
Ma'am, can
Yes.
you repeat once?
So this will be your chord, right?
Yes, ma'am.
And suppose a line you have drawn from center. So it
Yeah,
always
ma'am.
bisect this, right? So it means that let it be M. It means the AM will be equal to MD. Fine, beta. And
Ma'am
PM
is
will be equal to MD.
ma'am,
Yes, bacha?
is AB a tangent of the inner circle?
No, not a tangent. These are the chord. What is
Oh,
your
okay, ma'am.
chord? Yeah, chord.
Okay, ma'am.
So what you will do? You will do the construction. Now they are saying that the radius of the smaller one is 3 centimeters. So this will be 3 and it will be 5 centimeters. Right, beta? So you can find by Pythagoras theorem AM or not.
Yes, ma'am.
So it will be under root 25 minus 9 under root 16. So AM will be equal to 4 centimeter. Right, beta? So your chord will be, because they have asked, find the length of the chord of larger circle. So it means you have to find the chord of length of AB. So it means AB will be twice of AM. So 2 into 4, 8 centimeter. Is it clear? This type of question came in MCQs.
Ma'am,
Understood?
what if we have to find the length of chord of the inner circle?
Larger circle.
Like,
Oh, no,
what
I'm
if we
asking
have to
what
find
if?
them?
Yes. So these are, AB is the larger circle chord, no? Which is having a radius 5 centimeter.
How do you
Yes,
find CD, ma'am?
CD is the chord of smaller circle.
Like, if I really want to measure that.
ma'am, like how do we find the length of CD?
See. AM is how much? 4 centimeter.
Yes, ma'am.
And CM is the radii of the... No, this will not be radii. So you will join with this na point of contact. Then you will
Okay,
apply
ma'am.
the radius of this. You will apply Pythagoras theorem. But it will not be equal to this. Just wait. This is 3 centimeter. This is 3 centimeter on. Clear?
Yes, ma'am.
This is not given, and this we have calculated. AM will be equal to, this is AC, AM.
Ma'am, we are finding CD now, ma'am. No.
Just wait. We have to draw the figure like this only. Just wait. Figure should be like this. This is your first circle. This is your second circle. It will be like this. Short. It will be the tangent to the smaller circle. Okay?
Okay, ma'am.
Figure will be like this only. Just wait. Like this. This is OM. This is OA. And this is OP. Clear, beta?
Yes,
Now
ma'am.
it is clear. So this
Yes.
is 3 centimeter. Now understood this thing?
Yes, ma'am.
Okay. Please note this. Hurry up. Written, children?
Yes, ma'am.
Yes, ma'am.
So, children, your today's homework is
Statistics
that,
worksheet.
Yes,
yeah,
ma'am.
so you will
Statistics
revise
worksheet.
both the theorems. Listen to me carefully. You will revise both the theorem, plus you will do your worksheet. Okay? And tomorrow I will take your test of these two theorem within the class only. Fine?
Okay, ma'am.
Okay, ma'am.
Yeah. And kindly turn on your videos also in tomorrow's class.
Yes,
Okay, ma'am.
ma'am. Thank you, ma'am.
Yes.
Okay.
Bye.
Thank you,
Bye-bye,
ma'am. Bye, ma'am.
children.
Bye, ma'am.
Bye-bye,